Good morning, everyone. Welcome to another episode of Xah Talk Show. Good, I'm alive. Today is 2019, July 18th, 3 o'clock p.m. San Francisco time. Today's topic is programming and programming languages. Okay, and we have a appointment with some of my readers, yesterday. So we set up a time today. Um, I hope they come. So today's topic is gonna be programming, kind of randomish topics, the programming related stuff. So let's go to first of all, go to my programming blog. Okay, and okay, starting Firefox. Programming blog, let's move it here so you can see my window. That's good. Okay, programming. So what we're gonna talk about today? I don't know actually. I just scrambled. Good morning, guys. Good morning. Say hi. So let's put the date. I wait for people to come on. Maybe. So Xah Talk Show. Today's date. Topic. Random. Okay. Programming related. Programming and programming languages. Fascinating subject. Okay. And hey guys, type your thoughts. Okay, type it here. So that's the topic. So what are we going to talk about? Okay, let's talk about. Let's see. I need to review this article. Why does okay this one is a very interesting topic. Let's talk about that. What does symbolic language mean? Now, if you code Lisp, if you know any Emacs Lisp, Scheme Lisp, Scheme Lisp, Racket Scheme Lisp, or Closure, or Mathematica, also known as Wolfram language, then you notice that these languages deal with symbols. I'm gonna show you. Okay, I can do some demo symbols. Okay, let me show you one obvious example of symbols. Okay, let's start. Hold on a second. Let's do this. Since I'm in Emacs, I'm going to show my Emacs commands for those of you who are using Emacs. Okay, so hold on a second. So Xah start command log mod. Okay, now in this window, you can see every command I call in Emacs. If you are an Emacs user, that's useful. So let's go back to three people. Okay, say hi. Okay, say hi here. And so what is symbolic programming language? Let me show you. Okay, symbolic. Now, if you code in Emacs Lisp, you will know. Um, okay, hold on a second. So, wait. So Lisp Emacs Lisp. Okay, so Emacs Lisp. Okay, now I show the code. Let's say magnify. Let's say plus 1 2. Okay, I evaluate the code. You can see 3 at the bottom. Maybe you cannot see it, but let me show you then. Okay, so let's open a new window, and let's go to the messages buffer. This is where all Emacs messages come out. Error messages or whatever. So here. So you see, let's do 1 plus 3. Okay, wait, hold on a second. We need to move it down. So let's do 1 plus 3. Okay, evaluate. You can see the result is 4. That's Emacs Lisp. Okay. Now, so let's set x equals to 3. Okay, evaluate it. Okay, it's done. Now let's message, which means print x. Okay, evaluate it. You can see the result here, 3. it's a string, because you are printing a message. It's like print. You can also use print right away, but we are not, this is not a tutorial about Emac Lisp. That's some other day. So anyway, so we have now set x equals to 3. Now there's an interesting thing about symbolic languages. Now this x is symbol. The same thing as, this sex, set, q, this message, they are all symbols. And what does that mean? That means you can get x without it becoming 3. So maybe this is strange to you, but let me, if I show you a Python example, you will know what you will know. Let's start. Let's do JavaScript then. Okay, so let's go open a new buffer, and let's see console log. Wait, let's say constant x equals to 3. Okay, let's just say let x equals to 3. And now let's console log print x. Okay, now this is JavaScript. Now I'm gonna run it. You can see the output here, 3. You see, but once a variable has a value, you don't have the x anymore. I mean, perhaps this how do I explain this? Let's go back to Lisp. Okay, Emac Lisp. You see, in Emacs Lisp, you can print the value of x, but however, you can also print the symbol itself. Now look at this. Okay, let's comment this out, and let's call this evaluate this buffer. Okay, remove that. Okay, let's keep it. So evaluate the buffer, and what we get. Let's see. Message. Okay, so okay, yeah, evaluate this line. You see, you got this kind of like a string. You got a string x. Well, yeah, because let's say we so you got a string, and but this thing is symbol. Let's see, symbol, symbol q. Okay. Let's see, describe function symbol. Okay, oh, symbol p. Yeah, why is not showing up? Not q, man. P. P. Okay, now symbol p tells you whether something is a symbol. Let's say 3. Let's do this. Okay, message, message, then we print symbol 3. That tells you whether Emac Lisp considered this thing is a symbol. Let's evaluate that. This window, it's annoying. Nil. Okay, you see the result there. Evaluate. You see it says nil. Nil means false. So this 3 is not a symbol. But however, if we do this again, let's check if symbol x is a symbol. Let's run it. It says nil. Okay, now but if we can do this, then we run it. It says t means true. Okay, so you see, so the point I'm trying to say is that in Lisp, any identifier, so-called identifier in other languages, in Lisp they are a symbol. And same thing with Mathematica. So that is why sometimes it's heard, it's said they are symbolic languages. Now in Python or JavaScript, you cannot do that. Like you have an identifier. Identifier is, evaluates to a value, or whether it's a name of a function. It itself is not something that exists. It's just an identifier. So do you see what I mean? So do we have people, 5 people? So say hi. Okay, so where did those yesterday the Bathelo JS guy, where did he go? Are you here? Okay, so anyway, so let's see. Yeah, 3 o'clock. So anyway, so I demonstrate a little bit what the symbol, the symbol in Emacs Lisp, and this is in other Lisps. So for example, Scheme, Racket, Closure, Common Lisp, they all basically have they are like this. They all have you have symbols. So the question I'm asking is, what does symbolic language mean? I mean, yeah, okay, so you know, we understand that instead of identifiers, you have like the symbol concept. But what does it do? Like, what is the utility? I mean, why do you have symbols? That is the question. So I was, because this is interesting because I was a Mathematica programmer for like 15 years, from 1992 to about 2005. I haven't coded Mathematica for like 10 years, but I was a heavy Mathematica coder, and also I am a Lisp coder. Especially Emacs Lisp. So you have these languages, you have symbols, but what does it? What is the significance? That's an interesting question. You see, sometimes people you wonder, so what's the difference between Lisp and other languages? I can tell you what is the difference. The number one, the most fundamental primary difference of Lisp languages and others is that Lisp has symbols. This concept you don't find, basically you don't find in any languages, like not in Perl, Python, Ruby. Well, I think Ruby also, not in them, not in Perl, Python, Ruby, JavaScript, Java, C, C++, even Haskell or Camel. You don't have symbols in any of them. Although in Ruby and JavaScript, you have something like a symbol type, but that's not the same thing, because in Lisp, every identifier, like every one of them, variable names, function names, built-in function names, operator names, such as and even the plus sign is a symbol. Okay, for example, let's see if the plus sign is a symbol. Let's run it. It says true, you see. So in Lisp languages, everything is symbol. It's called symbolic languages. So what is useful? What is the purpose? I mean, what is the significance? The significance is that I learned, this article I wrote in 2005. Oh wait, no, I did not write this in 2005. That's a mistake. So let's correct that. Okay, so let's correct this. Let's go to, so I wrote this in 2016, not 2005, and let's update. Yeah, so 2016. So I wrote this. I asked the question. So it turns out, it seems the answer is that the significance of symbols in a language like Lisp, symbolic language, is that they allow rule-based transformation, rule-based programming. It's called rule-based programming, or also known as term rewriting languages, term rewriting system. If you may not have heard of that, but you can see on Wikipedia. Term rewriting, rewriting systems. Let's see, rewriting. Okay, let's go through this article. So it says, in mathematics and computer science and logic, rewriting covers a wide range of potentially non-deterministic methods of replacing subterms of a formula with other terms. Okay, The objects of focus for this article includes rewriting systems. Okay, in their most basic form, they consist of a set of objects plus relations on how to transform those objects. Okay, well, but this article gets a bit abstract. But basically, what happens is that term rewriting system is that you can transform term rewriting system is that um, term rewriting pattern matching. Okay, yeah, for term rewriting system, that's kind of a technical mathematical computer science term, but in practice what you have is basically pattern matching, symbolic pattern matching. Okay, meaning that for example, regular expression. Now regular expression is not term rewriting. Okay, it's not symbolic term rewriting. Regular expression is a it works on strings. Basically you can replace patterns in strings into some other string. So that's a replace. That's kind of like that is actually technically also a term rewriting system. But anyway, in most languages, when you have a regular expression, it works on string data type. Now in Lisp, in Mathematica in particular, you have you have regular expression, but you also have what's called symbolic pattern matching. So what is symbolic pattern matching? It basically is just like regular expression, except you don't. It's not working on strings. It's not replacing part of the string. Rather, you replace the whole source code. For example, this is a pattern. Now, for example, uh, this pattern, I can make it a string. For example, in let's see. Okay, so for example, now it's a string. Then I can use regular expression to, maybe, find out which, this part and this part in the middle and this part. I can start to parse it, and maybe replace this part by some other thing. But the whole thing must be a string. That's regular expression. But when you have symbolic pattern matching, you are not dealing with strings. Rather, you deal with this whole expression directly. So you can create a pattern in Mathematica. For example, Lisp doesn't have it. What Lisp has is macros. We'll talk about that. But anyway, so this the whole source code is a pattern, and you can write a rule like pattern replacement, like regular expression, to replace any part of it. So that is what symbolic pattern matching is. Now in OCaml and Haskell, those functional languages, they also have pattern matching, but their pattern matching is not symbolic because their language is not symbolic. So what they do is that when they have a pattern matching, they match on the values of expressions. Any expression like a variable or more complicated expression. For example, a list, a structure, a list, a hash table. A expression. That's an expression. You can match. You can match the pattern. Let's say the first element versus the rest element. That's a common pattern in Haskell or Scheme, these kind of languages. You can find out the first element versus the rest element. Then you can replace the list by the rest or any other elements, the last element or the third element, things like that. Pattern matching, they match on the expression's value, typically the structure, like a list or a structure, or the type. Sometimes also type are part of the pattern matching. So for example, if you have a list of many things, if you have a list of elements and each element is also a list, okay, let's say, but the first element of that list, maybe some of them may be a number, some of them may be a string, for example, but you want to filter the whole thing. You want only lists that the first element is a number, for example. So you can use pattern matching for that. You just say the first element of a list, list is a pattern. The first element must have the type number. So that's Haskell and OCaml. I don't know these languages. I don't really know them, but that's what I understand. That is the situation for their pattern matching system. It's based, they match value of expressions typically by the structure and type. Especially like OCaml or Haskell, they are strongly typed. But how is it different from symbolic pattern matching? Symbolic pattern matching, because it's symbols. For example, this whole file is a sequence of characters. That's a pattern. It's almost like a string, but it's not a string. So you can now match the whole thing, the whole thing, without not evaluating, you know like any of these, not evaluating them. You are matching the raw source code. That's symbolic pattern matching. Now, the most obvious example in Lisp is called macros. I don't, Lisp macros is very idiotic, because Lisp macro is the you can, it's actually the crippled kind of the beginning form of symbolic pattern matching. It's like, very small subset of it. But I'm not going to code the list macros. I never code. I do not ever use list macros, because I think it's idiotic. So but anyway, that's the most famous example. And many languages, they think because of Lisp, so many other languages, such as Julia, I think, they say in their feature list, they say, oh, we also have macros, like Lisp. That's no good. What you should have is pattern matching. And um, for languages that are not symbolic, I don't think Julia is a symbolic language. So when they try to do macros, they are kind of like, I suppose they are kind of creating some, idiosyncratic way. It's not systematic. You see, the reason Lisp, you have symbolic language, the whole thing is symbols, is that so that the whole, source code can be treated as like as a data, as they say, as inert. You can choose to evaluate it, or you can choose not to evaluate it. Just take the whole source code or part of the source code, like an expression unit. Then you can do transformation on it. That's what Lisp macro does. But Lisp macro is very, very rigid, and not is it's very it's kind of a hack. What you really want is symbolic pattern matching. That's the full, you know, let's say, symbolic pattern matching feature of Mathematica has, 100 things, let's say score of 100. Then Lisp macro is like 5%, like 1% of it. So that's a gap. That's how different they are, between these macros versus the symbolic, true symbolic pattern matching in Mathematica. By the way, there are other symbolic pattern matching rule languages. So that, sometimes they are called term rewriting systems. Um, So, are you any guys of you here? So say hi, okay? Say comment, post comments or opinions, okay? That way, the the talk gets better, because otherwise, I don't know where to go. But anyway, so let's go back to the. I'm talking about the. Okay, here's an article: Proliferation of Computer Languages. This I wrote in 2008 because beginning. Let me tell you the story. Beginning in 2008 or around there, 2005 to 2008. Okay, I would say. Uh, you start to notice that there are so many more and more languages every day. That's the beginning 2008, not before that. Basically, around 2008 or 7. So this is my observation. This is my the information I want to give out, because when you ask other programmers or the programming forums, the hacker news, they don't they all vast majority of their opinions are just crass. So anyway, so what I'm saying, I'm telling you that if you observe, as a part of human history, if you say, if you historians look at computer languages, there is a period of time around 2000, late 2000s, that we started to see a explosion of computer languages. Okay, that is what I'm saying. Historians will have this item, and that is around 2008. And okay, so so I wrote this article, and some of my opinions. Then it's a collection of languages, like new languages. For example, this language, pure, is a pattern matching language. Pure is a dynamically typed functional programming language based on term rewriting. Okay, it has facilities for user-defined operator syntax, macros, multiple precision numbers, and compilation to native code. Blah blah blah. You know, Wikipedia wanted to remove. At one time, Wikipedia wanted to remove this article. Pure came from another language called Q, which was like they tried to improve it by the same guy, I think. I haven't tried the language, by the way. So stable released April 2018. Okay, so it looks like still active, but I've never heard anyone else mention it though. This language, pure. But anyway, this is a pattern, and this language can do pattern matching. Now, okay, so for me, the next question is is this language symbolic? I don't know. So that would be interesting to know, because that's related to our question. Because I don't know. I have still things to learn, so I don't know if is it true that all uh, term rewriting systems necessarily require the language to be symbolic, like the way Lisp or Mathematica is. Is that true? I do not know for sure. So pure would be something I have to look into. But anyway, this article, I list a bunch of new languages. You have pure, you have Vala, Genie, you have Factor, you have Phantom, Phantom language. I don't have a logo. CoffeeScript is kind of dead. You have Dot is also kind of dead. Google, Google's Dot. They are trying to replace JavaScript by Java. That's what Dot is. Dot is Dot is Java in Dot is JavaScript in Java syntax and also in Java semantic. Basically, Dot is everything. It's just like Java. Okay, Google wants to make JavaScript to become Java like. No good, and they fail. Nobody is using it, but they are still like alive though. They are still doing something with it. At one point, they try to tell other browsers to put Dot into into the browser. They try to tell Microsoft and Firefox, and both refused. This is like 5 years ago or so. They all refused. Apple also refused. Um, you see, So there's the article. What do Microsoft, Apple, Mozilla say about Dart? They all refused. Hey, good morning, Lynch. What do you know about SQL corrupting? No, I don't know nothing about that. What does that mean? SQL corrupting. Yeah. So what does that mean? So anyway, this page, a list of languages: TypeScript, Go, Rust, Julia, or Meta, Elm. There's so many hacks, Hack, Swift, Elixir, Kotlin, Nim, Crystal. uh, Nim language is very fast. It's like Python. Python in with C speed. That's what Nim is like. Crystal is like Ruby with C speed. That's Crystal is like. Pirate is like Lisp in Python syntax. That's what Pirate is like. Pirate is basically created by these the racket scheme people, because scheme, Lisp basically failed. They so they had to they started to use the Python like language, Python syntax. Then you have pure script. You have so many, like there's an explosion of languages. So let's go back to this. So what does symbolic language mean? So okay, let's summarize. Mathematica and Lisp, these are languages that are so-called symbolic. That is, every identifier, every name, every variable name, function name, even operators, they are symbols. And they don't, so a symbol has a value, or it may not have a value, or it may be kept unevaluated. So when symbol is evaluated to a value, then it's similar to other languages. For example, variables becomes a number or a string or something. A function, such as message, it's a value, it's a function, it does something. But every identifier in Lisp or Mathematica, they can be hold unevaluated. In Lisp, it's called quote, like this, okay? Or it can also be written like this. I'm gonna show you. Oops. Quote x. Okay. So this quote x, this is exactly the same as that. This and this are exactly the same. They are syntactically equivalent, meaning that when Lisp compiles it, these two things are exactly the same before it even start to compile the code. Yeah. So in Lisp, it's called quote. Quoting, it's called quoting a symbol, meaning it means do not evaluate this symbol. Like do not evaluate it. Instead, what you want is the symbol itself, the symbol itself. So that's, so Lisp, Mathematica are symbolic. So what is the purpose of symbolic languages? That is my question. And as far as I understand, the symbolic language, the purpose of symbolic languages is that they allow uh, uh, symbolic pattern matching, which in other words is they allow the feature of term rewriting. Okay, meaning that you can take the whole source code, or an expression of a source code in a symbolic form. Basically it just means you can do transformation on the source code. Okay, that is what term rewriting or pattern rule based pattern matching means. Rule based, it's also called rule based programming, because a rule is basically like a specify which pattern should become which, like a transformation rule. So you have a bunch of transformation rule. So when an expression is evaluated, for example, when this expression is evaluated, the system will try to see if the pattern matches, of the some of the rules. If it matches, then the rule will apply. So the pattern, your expression becomes something else. It got transformed. So that's rule-based programming, or the feature is called symbolic pattern matching, and the mathematical term for this kind of system is called term rewriting system. Okay, so that's um, so the purpose of symbolic language, it seems to me, is so that they can have this term rewriting. It is a way to achieve the feature of symbolic pattern matching. Yeah, that's how you say it. But what I do not know is whether it is a necessary requirement. That is, if you are going to do term rewrite, if you are going to create a term rewriting system language, do you require that your language be symbolic? That is a question. The way like Lisp or Mathematica. That is a question I don't know. Okay, that kind of concludes my discussion about this. But there's one addition. Let me mention. Okay, so Lisp, and Mathematica, they are symbolic, and they do, they allow pattern matching, symbolic pattern matching, or transformation of code. But why is this useful? I mean, what is it useful? What is the actual use of that? The actual use, well, in Lisp you have macros, which allows you to. It has some, it's useful because it allows you to hold some expression until and evaluate them at the later. It allows you actually to transform the code. uh, let me show one example then. For example, if, okay, let's see, if, okay, so if x equals, let's say if x, okay, message, uh, okay, let's just do that. Let's say that, we have a if expression. If x is true, then print yes, otherwise print no. Now, if is like a function, because in this, basically the beginning of a parenthesis is a function. So if it's a function, typically a function will evaluate the first argument. Then, the argument to a function, we have a if it's a function, and right now we have three arguments: x, and that, and that. Three arguments. Now, normally, when you call a function with arguments, the arguments themselves will be evaluated. So x will become 3, for example, and this message will print right away, like evaluate. It will be evaluate, so it will print yes, and then here it will print no. And so normally when you call a function, all the arguments will be evaluated. But if you have a function like if, this doesn't work, because the purpose of if is that you don't want some of the, you only want to evaluate depending on this condition. So you have a problem here. You have a problem. How do you, so the question here is, how do you write a function? How do you write your own if function? You cannot, because when you call a function, all the arguments get evaluated. So that is the issue. But in Lisp, you can do that because macros. So what does that mean is that you can define a function called myIf. Okay, let's say myIf. Okay, you can, let's say, let's copy that. myIf. Okay, you can define a function your own myIf. such that when it is called, the arguments, all the arguments are not evaluated. They are rather, they are held in their symbolic form, just like that. They are not evaluated. Then in the function, in the body of your function, you can tell it, Lisp, to, how do you want to transform these these expressions. In your body of the code, you can say, okay, if x is true, then you evaluate this argument. Okay, otherwise then you evaluate that argument. So that's how you write a if, by a key macro. You can say diff macro. That's how you do it, but I don't use macro, so I'm not very familiar with the syntax and all, and to show you, so I cannot show you. um, well, I should get I, if I prepare, for an hour, I'll be able to, but I don't use macros because, so anyway, so that's what macro in Lisp is about. They let's review. They allows you to hold expressions, like don't evaluate it. Then in the body of the macro, you can tell, the language, how you can do transformation. Like you can do whatever you want. You can manipulate the argument. Then you can tell, when to evaluate certain part of it. That's what macro does. This macro, which is a which so this is the beginning of pattern matching. Remember, we talked about pattern matching. So list macros is like a very small part of the whole symbolic pattern matching, because holding the form and transformation, that's what pattern matching is about. That's the whole topic of pattern matching, symbolic pattern matching. Okay, so you have macros and you have pattern matchings, and what else is it useful? I mean, so the most useful about symbolic pattern matching is in computer algebra. In computer algebra, for example, you have, for example, x plus y. Okay, let's say raised to the power of 3, uh, you know, something like that, or 30. Okay, you want to you want to expand that. For example, if you don't know math, let me show you. So this expression means, for example, this expression means that, and that will become x squared plus 2xy plus y squared. Okay, so if you multiply this out, it will become that. But now, what if you have that? How do you gonna do? What you gonna do? Or if you have that, for example, you want to factor it. You want to get this form to this form. You want to factor polynomials. How do you do it? So this is when symbolic pattern matching, rule-based programming, the transformation of code sequences becomes critical, becomes very useful in computer algebra. And also other examples are, derivatives, linear algebra. Algebra, you have a matrix times a vector, two 10 by 10 matrix times a vector. And you can do it numerically, but sometimes you want it symbolically. You want this, symbolically. If Let me show you an example. For example, matrix. Okay, m equals to so we have that to 1 2 1 2. Okay, so 3 4. So that's a matrix. Okay, and a vector is, for example, AB. Okay, let's replace. Let's say A B C D. Okay, let's say the vector x y. Okay, now you want to multiply them out. So makes matrix times hold on a second, let me write it out. So if you have a matrix and a vector, and if you want to multiply them m times v, and the result will be ax plus by, okay, and cx plus dy. That is a symbolic result. So if what if you want a programming language that can, you can define a matrix like that, you can define a vector, and you want this result. Notice that you want it symbolic. You don't want, in the beginning you don't have numbers. You don't want numbers. You want these. That is when that's called computer algebra. The computer algebra systems. That is why you want to use. That is when the rule-based programming, the pattern matching, symbolic pattern matching becomes extremely useful. So Lynch, no more questions about that. SQL, what was the question? SQL corruption. SQL corruption. So otherwise, I think that's it. Nobody's commenting. What happened to that Mathelo Meow JS? My God, yesterday he said he's gonna come up. So I think that's it for today then. We talked about, 40 minutes. We spent 50 minutes talking about symbolic languages. That's a good topic. So the question is, what's the significance? I don't know the answer 100% yet. Because I'm exploring. They say as long as you are alive, you are learning. There's always something to learn. So I'm still learning. So I wanted to know what is the. So let me talk about. So why is this question important? What does it matter? Okay, you have some languages are symbolic, some are not. Why? I mean, is it important to know why does symbolic language mean? I mean, it's just a feature. I mean, you can say, oh, okay, some language they just design like that. They have symbols. That's it. But my point is that you see, here is the question that makes this question interesting. Okay, you see, as programmers, we usually think about. We often people talk about a perfect, ideal, general language. People are thinking, wouldn't it be great if we have one general purpose language, and this language is so well designed that it can do anything. Like it's a general purpose language, but it's so well designed it can do lots of things. So here's the interesting thing about that. Now, first of all, the question you want to ask is that, okay, so you have this ideal generic purpose language. Question: does your ideal language can it solve equations? Like can it expand polynomials? Like this is a simple problem. You just multiply a polynomial out, or symbolic compute the matrix and vector multiplication product symbolically. So does your general purpose language do that? So what do you say? I mean, what do you say? Your ideal general purpose, do you think it's good to have that? This. So in my opinion, these are really significant. This math symbolic processing. It's great to have. It should be. Ideally, okay. We are talking about ideal general purpose languages. So ideally, it should include this kind of capabilities. Okay, it should in an ideal generic purpose language. Now the next question is, okay, so if you want your language to be able to do symbolic, this math, computer algebra, the basic, at least the basic ones, then is it required that your language be symbolic like the way Lisp and Mathematica are? That's a question. That's an interesting question. So if it is required, then we have a problem. So if it's required, then you can see that all the general purpose language, Java, Golang, Perl, Python, Ruby, all of them, they are not symbolic. So so to us, to the us, the programmers who want a ideal generic programming language, all these are crap. All those languages failed. Golang, Rust, Golang, Haskell, they are failures. They all failed because they cannot simply do such a simple thing as a symbolic matrix multiplication. They cannot even do that, so they failed. So that is why this question is interesting. On the other hand, if in order to do basic symbolic computation, computer algebra, if it is not required that the language be symbolic the way Lisp are, then that's a good answer. Then that means, okay, Golang, Haskell, or whatever, or something you might think of creating, you know it's possible. You can do that. So that is about that today for today's talk. So Nicholas Leo says, "Hey Xah, I would like to learn more about Lisp macros because there are some interesting uses of metaprogramming in Julia, also similar to template metaprogramming in C++." Okay. Uh, okay. So some questions. Let me answer. Okay. So Nicolo's question about, so he likes to learn more about Lisp macro, and he says that because there are applications of metaprogramming in Julia and also template metaprogramming in C++. Okay. Okay. So do you have a question or is that just a comment? Okay. So in C++ in Julia, so yeah, they also have there are few things to talk about that. Okay, so one of the thing, interesting topic is what is the nature, what is the nature of macro in Julia, and what is the nature of macro in C++. C++ has these templates. I don't really know C++, and I don't know Julia neither. So in pursuit about question about symbolic programming, it would be nice to know. So it's something to look into. So you have to spend a month or a week study. I would have to study C++, know exactly what's their template system, and study Julia macro, see how they differ from Lisp, things like that, and how they compare to the real symbolic pattern matching. Off the bat, I think they are not comparable to symbolic pattern matching. They are just like little tricks here and there. I don't know. Yeah, that's what I think because the Lisp macro is like that. It's like, as I mentioned before, if Lisp macro is a feature, then symbolic pattern matching system in Mathematica would be like 10 times more powerful. It's like 10 times stuff. So anyway, so Lynch is beginning to learn programming. So what you should learn first. So if you are like average, I mean, if you are normal, the primary thing you would be concerned is be able to find a job with the language. So in that respect, Python is good to learn. Golang is good to learn as a first language. Okay, so yeah, so like if you ask this question to different people, they will give you different answers. Like every language, depending on which language they are a fan of. But in general, Haskell is good. I mean not Haskell. Okay, Python is good to go. So Ruby is also good. Ruby, Python. JavaScript is kind of screwed up, but yeah, it's not really good for beginning language. Uh, Golang is okay. Yeah, I would say so. Golang, uh, Ruby, Python. Okay. So yeah, so I haven't worked with C++. I don't even yeah, I haven't. I never coded C++ actually. So Danielle Langlois, good morning. Uh, does Mathematica have macros? My God. Well, did you just came to the show because the whole hour we were talking about that. We were talking about the details of lisp macros in Mathematica. Let me answer the question. Okay, actually, there are people who ask that. Does Mathematica have macros? The answer is Mathematica, the programming language, the entire language is based on symbolic pattern matching, or it's also known as rule-based programming, or in academia it's known as a term rewriting system. The whole thing, how Mathematica computes, is macros. Okay, that's what I'm trying to say for the past 15 minutes. The entire language, there are two ways Mathematica computes. One way is just like every normal language. You define a function, you have loops, you have, or you do functional programming, that's one way. But the other half is symbolic pattern matching, meaning that whenever you write a function, it's not actually a function. It's a rule that tells you which pattern becomes what other pattern that works as a function. So when Mathematica sees an expression, it tries to see which rule applies. When it applies, it uses the rule to do a transformation of the expression. Then that result, the whole thing repeats until there's no more rule matches. It's like a grammar when you write a compiler parser. It's like that. That's called symbolic pattern matching of Mathematica. So I have been saying Lisp macro is kind of like that, but it's like 1% of this whole thing, 5% of it. That's that. Uh, so to do so like there I've seen people on Stack Overflow who ask does Mathematica have macros. Then I have seen like the best answer that says oh yes and no and blah blah blah. That's like 100% idiotic wrong. They don't know what they're talking about. I know because I have, I would claim I'm the top 100 Mathematica coder in 1990s at least. Okay, well, okay, I'm bragging. A lot of people, will be turned off. But anyway, that's what it is. The whole system is a you can call it macros, but it's macro is just the wrong word. Okay, macro is the stupid word. What's it really called is called symbolic pattern matching system. It matches expressions, it transforms, and or you can call it rule. When you do programming like that, it's called rule-based programming. In a typical Mathematica code, source code anywhere, like 50% of it is using patterns like rule based programming, transformation of the patterns. So in other words, the whole thing is a macro. It's just a giant macro that's running macros. Everything is macros. So that is why I despise, the Lispers with their macros concept. Because when you actually know Mathematica, you don't have to know the whole thing. You just spend, half a year to study Mathematica, learn the pattern systems. You'll see, like in fact we can like let's show Mathematica patterns. Let's show some concrete. Let's look at what it exactly looks like. What patterns? What are you talking about? Let's have a look. How you can see how it is a macro or how it is not a macro. You can start to see if you study this. You can see how the Lisp macros, like common Lisp scheme, they are extremely idiotic. They are like fuck and they are trumpeted by these lispers all day, day and night. These lispers, they don't know nothing. So, well, Mathematica, I'm not going to go into details because because then you have to explain the syntax and you have to explain. There's a lot to explain. But let's see if I can. Um, yeah, there's a lot to in order to kind of explain how it works. The basic. It'll take some time. It'll take half an hour, but I have a introduction essay. If you are interested, for those of you lispers who are interested in looking into what this whole pattern matching means, you can read this article. This article will explain. Okay, Intro to Mathematica Pattern Matching for Lisp Programmers. Okay, this is written in 2008. I show you some concrete problem, a programming problem where given a list, you want the result to be some, selection of it or something. And you can see some examples how to do that by patterns, by using, patterns. And I also show, Lisp solution. You can compare, Um, but however, this problem cannot be done with Lisp macros. That's the thing. Because Lisp macros is puny. It can do nothing. All it does is that basically what Lisp macro is that when you have a function, then you have a bunch of arguments. What Lisp macros allows you to do when you say diff macro is that it can hold the arguments not evaluated. So you have these arguments as is, without evaluation. Then in your body you can say what to do with them. That is all this macro is about. But on the other hand, when you think of the whole thing as a pattern matching, what happens in terms of symbolic pattern matching is that you have a function called expression, that which is an expression. That's a pattern because you have a function name, then a bunch of arguments. That's a pattern. Then you can define a pattern such that each of your argument is for example in Mathematica is it's this form. It's this form. Okay, x underscore. That stands for any expression argument. And we call it to be referred to as x. Okay, so the list macro, if you look at it in terms of symbolic pattern matching, what it is that you have a function expression, very simple pattern, function name, a bunch of arguments. Each argument becomes a pattern. You can name it x, y, z or whatever. Then you can do whatever with it. That's it. So the only pattern we are using is this one, x underscore. You see, but Mathematica has all these others. You see, blank sequence, blank null sequence, and lots of. And you can compose them. You can combine them. So it's a that's what it is. Essentially, it's like a transformation of code. So no, that's a common question. Because I happen to be, Mathematica happens to be my first language, and it so happens I'm a big fan of math. So I spent 10 years, more than 15 years to code Mathematica all day. In the 1990s, I don't even know anything else. I don't know the basics of computer languages, what it means. I don't know nothing. I only know Mathematica because I read the manual. That's 1,000 pages. I read it 3 times, cover to cover, in different years. Because I'm into math. So Mathematica is my first language, and it's also the first language I learned, thoroughly mastered it, for over 10 plus years. And I went to work for Wolfram Research because of that for a while. Then my case is a bit different, because So I'm Mathematica, that's my first language. Then my next language is, I started to do industrial coding. I started to learn Perl and Unix. Then I started to find out they are just totally different. You see, so they are completely different, and they are not comparable to the so Mathematica. So you don't, so so why is Mathematica so different? For example, because first of all, it's symbolic, like Lisp. That is already rare. Except so you have Lisp and Mathematica, nothing else. Golang, all the other language are not symbolic. Okay, so that's why Mathematica is like out there. But then you have symbolic pattern matching. You don't find anywhere else. In Lisp you just have like tiny macros that so-called macros. That's it. But Mathematica, you have the whole symbolic pattern matching. I don't see it anywhere. In Haskell, in OCaml, they also have pattern matching, but as I mentioned before, their pattern matching is not symbolic. It's rather based on structures and types. Um, in Mathematica is not typed. So all these patterns, you are truly really matching the characters, like each which character follows by what. That's what you are matching. You are not matching say nested list or type of something. That's not like that. So actually I should end the video. So I've been talking for an hour, so that's a good talk today anyway about this topic, focused on this thing. So let's see the comments. Programming have Mathematica in general. What do you mean? So Danielle says I can bash Mathematica. For example, I don't like that sign that is how you write sign that. Oh my God, Danielle, you asked the right person for that question because I can talk about that for 1 hour. The reason for that, okay, is actually because Mathematica is the actually that's a whole topic about math notations and how the consistency and or abuse of traditional math notations, and also the question about what is the proper solution, ideal solution for computational mathematics. Okay, that's a whole topic. I have like tens of articles about it. So the reason Mathematica's syntax is like that, they use square bracket, is because so that way each bracket, may it be parenthesis, square, they have one unique meaning. Okay, that is not the case for typical math. For example, typical math, you have, for example, let's say sine x. Okay, sine x. Sine x magnified. For example, sine x. Uh, let's say plus 5. Okay, uh, times 3. Okay. Now notice there are two parentheses. There's parentheses here, and there are parentheses here. Now these two instances of parentheses, they have different semantics. They have different purposes. Here, it's used as a delimiter for functions argument. But here, it's used for grouping, for precedence. So that's inconsistent. That's a problem. That's a bug. Okay, that's a traditional math notation. That's no good. So Mathematica, that is why that. Okay, so okay, there are a lot to talk about that. So we talk about that some other day. Yeah, Mathematica. Yeah, we can talk about that. So thank you guys for. Oh, so if you want to learn Mathematica, oh yeah, you can, but it's expensive. That's a problem because Mathematica is not open source. You have to pay like 1,000 or something, more than 1,000. But they have a hobbyist version, which is, I think, I don't know, a few $100s, but which is identical to the professional version. Identical. Okay, so but you only pay few $100s. And there's also a free version. Free version is when you go to buy. Let's go to Amazon. Okay, this is my last 5 minutes. Last 2 minutes. Let's go to Amazon and Raspberry Pi. Okay, let's go there. And so Raspberry Pi includes Mathematica free. So if you buy Raspberry Pi, you can buy the whole kit. Okay, then you'll have Mathematica to play with. But of course, as you know, Raspberry Pi is very it's not very powerful. So if you really want to do huge computations, Mathematica's got graphics. It's a lot things. So well, but anyway, so if you buy this, it's free. Oh shit, I don't have let's see. Let's pick one. Let's pick this one. Okay, this one. So what I want to do is actually I want to post a link. I want to post the link with okay, with my name in it. Okay, so you guys can go buy it. Okay, so that's it for today. Thank you guys for watching. Anything else, type it. You have like 10 seconds, then that'll be it. Bye.